Hello and welcome back. Have you ever been asked to describe the runtime complexity of adding an element to the back of a linked list? Or how about describing the runtime characteristics of a Fibonacci series? These may or may not have come up at your last cocktail party, but believe it or not, these are some commonly asked interview questions from many companies in the Valley. And while they may sound Greek to you and me, in this section, you're going to learn to speak a new language. Not a computer language, but a language computer scientists and engineers use to describe the efficiency or runtime characteristics of their programs. And by the end of this section, not only will you be able to speak this new language, you'll be able to use it to describe the characteristics of your own algorithms, something called Big O notation. So what is this thing called Big O notation, and why is it used so much in our industry? Big O notation, also known as time complexity, is basically a measure of the efficiency of an algorithm. It's used all the time in our industry because early on, computer scientists and engineers needed ways to compare algorithms, which were faster, which were quicker, and which were more efficient. And Big O notation is something that came out of the academic world to describe the different runtime characteristics of all the data structures and algorithms that we use every day when we're writing programs. Now, we've already touched on Big O notation. For example, when we looked at arrays, we realized that random access to an array was something that was really a killer feature. It was super fast. We called that constant time. In Big O notation, that's O to the 1. Likewise, anytime we had to walk through an array, do some looping, and do some iterating, in other words, where the number of elements in our data structure increased and the operation took longer, we called that linear time. An example of that would be deleting a value from a linked list. So Big O notation is used to describe these runtime characteristics, and it's important to know because when you get into your interview, a very commonly asked question or something you may be asked to do is actually describe the runtime characteristic of the algorithm you develop on the whiteboard, on paper, or in code in the interview. So that's why it's really important that we start to get more and more familiar with this language, with this notation, and really understand what it means and how to apply it effectively in your interview.